Hello, I'm here in my bathroom. I want to do this demonstration for you to explain a little bit about specific volume. So let's consider this sponge. It's completely dry. So let's consider this and imagine this is a volume of dry air. If we try to put some moisture into that air, so I'm gonna open my tap here and I'm gonna wet it. So as it's getting wet, it's taking on moisture, and that moisture is mostly staying in. So there is a tolerance for that sponge to accept moisture. As long as that limit is not reached, the sponge will keep on taking moisture and will not drip or will not lose that moisture. If we keep on doing that, ultimately the sponge is going to reach a limit, and then it cannot take any more moisture, and then it's gonna start dripping. So this is what's happening to dry air. As long as you're taking moisture into the air, it's gonna get 10%, 20%, and then until it reaches 100% humidity, relative humidity, and then it will not be able to take moisture anymore. Now, until now we didn't change the volume of that air, so it is a constant volume. So let's consider what would happen if we shrink that air, if we make it smaller. So if you try to squeeze it in, because the volume is smaller, it's not gonna take moisture anymore, and the excess moisture is going to go out of that air. It's gonna condense from the air. So this is the same thing is happening to actual air when it shrinks or when its temperature goes down. So if you remember your high school physics, the temperature and volume, so the temperature, when the temperature goes down, the volume is going to shrink, and when that happens, the air tolerance to accept moisture will be less, and so it's gonna take that moisture out. I hope that explained a little bit something about specific volume, and this is an important concept to understand when dealing with moisture in psychrometry.